Good morning. In this video, I'm to introduce 9.4 Part 2 on buffers. This video will focus on one equation called Henderson-Hasselbalch equation. The Henderson-Hasselbalch equation states that pH equals pKa plus log of the conjugate base concentration over the acid concentration. This equation is used to calculate the pH of a buffer. It's commonly used in biology or environmental sciences when people try to prepare a buffer at a set concentration and set pH. Here we recall that a buffer is made of a weak acid and its conjugate base ion. In this case, HA is my weak acid and my conjugate base is A minus. And recall that pKa is equal to negative log of Ka. In this equation, if I know the concentration of the weak acid and the concentration of the conjugate base, and also the Ka value of that weak acid, I can determine the pH of that buffer solution. Recall the property of logarithm. It states that if log of 1 or log of 1 over 1, that is going to equal to 0, which implies that if the concentration of A minus is equal to the concentration of HA, in other words, if the concentration of my conjugate base is equal to the concentration of my weak acid, this whole log of A minus over HA term goes to 0. As such, pH is going to equal to the pKa of the weak acid. In words, if the concentration of the acid and the conjugate base is equal, pH is equal to pKa. What does that mean? Let's look at a few examples. We're going to come back to this line in a few moments. What is the pH of a buffer that contains 0.12 molar in lactic acid and 0.10 molar in sodium lactate? And you're given with the Ka of the weak acid. First question to ask yourself is, what is this question asking? It's asking me to find the pH of a buffer. In this buffer, I know the concentration of my weak acid, HA, which is lactic acid. So I can say in generic terms that my HA concentration is 0.12 molar. And what is my conjugate base concentration? After this weak acid gives away hydrogen, it becomes C3H5O3, which is going to be my conjugate base. So therefore, this conjugate base is the ion formed from this sodium lactate salt. So my A minus concentration is 0.10 molar. If you're still paying attention at this moment, send Mr. Chen an email detailing what is the conjugate base and how did we determine the concentration of the conjugate base. Now I can plug that into the pH equation or the Henderson-Hasselbalch equation. Here I'm going to say that pH equals pKa plus log of A minus over HA. A minus concentration, I can plug all the numbers in. Note that pKa is negative log of Ka, so I can expand pKa to negative log of Ka. Sometimes you're given with pKa already, but in this case, I'm just given Ka, so I need to convert Ka to pKa by doing negative log of Ka. This starting equation will be given on the AP exam equation sheet. So pH equals negative log of 1.4 times 10 to the negative fourth power plus log of A minus, which is 0.10 over the acid, which is 0.12. I can plug in the numbers and I get pH equals 3.85 plus negative 0.08, which is equal to 3.77. Note on significant figures. Here I'm performing an addition or subtraction. As such, the number of significant figures, you should keep the same number of decimal places as the number with the lowest number of decimal places. So here, both given values have 2 decimal places. If I'm doing a subtraction, I keep 2 decimal places as well. Further, I would like to state that for this Henderson-Hasselbalch equation, when the conjugate base concentration A minus is greater than the acid HA, pH is greater than pKa. When the conjugate base A minus is smaller than the acid, or pH is less than pKa. Those are two rules that would be good to memorize. I'm going to use this rule in this upcoming week. Let's look at another example. In this example, which of the following acid and conjugate base pairs have a pH of 7.5 when combined in equimolar amounts? If you're still paying attention, send Mr. Chen an email explaining what does the word equimolar mean. Equimolar means that the concentration of your acid and the conjugate base are equal, or they are same in terms of their molar concentration. So how do I solve this problem? If I see acid and conjugate base, I'm going to relate that to the Henderson-Hasselbalch equation. And according to Henderson-Hasselbalch equation, if my conjugate base and acid concentration are equal, this whole log term goes to 0. pH is equal to pKa. So using that rule, I'm going to go back to this problem. If they are equimolar, that means the whole log term goes to 0. So pH is equal to pKa in this particular example. So if I want the pH to be 7.5, I'm going to see which Ka value will give me a pH of 7.5. So I'm going to do this 4 times. I'm going to do negative log of Ka for the first one, negative log of Ka for the second one, negative log Ka for the third one, and the fourth one. If you plug each in a calculator, you're going to see that negative log of 3.0 times 10 to the negative 8th power is going to be somewhere around 7.5. Therefore, pick option C.